Hi there everybody. Today we are going to be doing our third lesson on arithmetic sequences. Before we begin, I'd like to quickly revise and just go over our formula. Our formula is Tn is equal to a plus d n minus 1, or Tn is equal to a plus n minus 1d. It's exactly the same thing, where a is your first term, d is your difference, n is the number of the term, and Tn is your general term. Okay, so that's the first set of things I'd like to revise. The second one is that I want you to remember that T1 is your first term, T2 is equal to A plus D, T3 is equal to A plus 2D, and T100 is equal to A plus 99D. You might be asking me, where am I getting this from? Well, let me show you. It's based on the formula Tn is equal to a plus d n minus 1. So remember I said to you that this n value, this value here, is the number of the term. So if I ask you to find T100, what I do is I substitute that 100 into where I see n. So it's a plus d 100 minus 1. So that's 99 times d, and that's what gives me a plus 99d. This type of information becomes important when we do the more difficult examples with arithmetic sequences. Let's look at example 1. Determine the first three terms of an arithmetic sequence of which the first term is 10 and the sixth term is 85. So how we set this out is that we say, well, T1 is equal to 10, which is equal to A, and T6 is equal to 85, and we use the information that we just learned now, A plus 5D. So T6 is equal to A plus 5D. What this becomes is a simultaneous equation, where that's your first equation, that's your second equation. And what we do is we substitute the value of A into this equation, giving us 85 is equal to 10 plus 5D. That gives me 75 is equal to 5D, and D is equal to 15. And with arithmetic sequences, what you would have learned by now is that when you have the first term and you have your difference, you can find your first three terms and any other term they give you, as well as you can also find your general term. So we see that A is equal to 10, and we've worked out that D is equal to 15, and therefore we can find our first three terms, which are 10, 25, and 40. Let's look at example number 2. It says determine A, the first four terms, B, the 10th term of the arithmetic sequence in which T3 is negative 4 and T7 is equal to negative 20. So we set this up again like a simultaneous equation, and that's the first equation, that's the second equation. Now, what we need to do, this is using the elimination method of simultaneous equations. Okay, so what we want to do is we want to make sure something cancels. So we're going to add or subtract these two equations to make sure that something cancels. So we're going to subtract them because we've got positive A and we've got positive A. And in order for the A's to cancel, we need to subtract them. So we're going to say equation 1 minus equation 2. So note the original sign was a plus, and that original sign is a plus, that original sign is a minus, but when we subtract the expressions, the signs will change. So that becomes negative A minus 60 plus 20. And what does that give us? A minus A will cancel, 2D minus 60 is minus 4D, and minus 4 plus 20 is positive 16. And what do? We divide by negative 4 on both sides, and we have D is equal to negative 4. We found D. Now once we find D and we find A, we can find anything in the sequence. So let's see if we can find A. So we said D is equal to negative 4, and if we substitute that into the first equation, we have A plus 2 times negative 4 is equal to negative 4. So that's A minus 8 is equal to minus 4, and minus 4 plus 8 is equal to positive 4. So our first term is 4, our difference is negative 4, meaning that T2 will be 0, T3 will be negative 4, and T4 will be negative 8. Let's look at our third example. It says the first three terms of an arithmetic sequence are 3p minus 4, 4p minus 3, and 7p minus 6. So you might be saying to me, but where are the numbers? Well, let's see how far we get. We're going to get to those numbers. So the first question says determine A, the value of p, B, determine the first three terms of the sequence, and then we need to determine the 16th term. So let's have a look at answering that first question. We have T2 minus T1 is equal to T3 minus T2. Where does this come from? You know that when we are dealing with arithmetic sequences, you know that when I say T2 minus T1, the answer must be exactly the same as when I say T3 minus T2. Why? Because my difference must always be constant. So when I set it up like this, T2 minus T1 is equal to T3 minus T2, I know whatever my answer is here, it will have to be the answer there because the difference has to be constant. So what I'm doing is I'm setting this up as an equation, and I'm saying 4p minus 3 minus 3p minus 4, which is T1, and then I'm saying T3, 7p minus 6 minus T2, which is 4p minus 3. What I'm doing now is simplifying, so getting rid of my brackets on both sides. And what does that give me? It gives me 4p minus 3p minus 7p plus 4p plus 4p minus 6 plus 3 minus 4 plus 3. So we've grouped all the variables on the left hand side, numbers on the right hand side. What does that give me? It gives me minus 2p is equal to minus 4, and therefore p is equal to 2. What am I going to do with that information? P is equal to 2. If p is equal to 2, let's go back to that previous slide. So let's substitute that 2 into 3p minus 4. So it's going to be 3 times 2 minus 4, which is 2. So our first term is 2. What's our second term? It's going to be 4 times 2 minus 3, which is going to give me 5. And 7 times 2 minus 6 will give me 8. Therefore, we can go ahead and say that the first three terms are 2, 5, and 8. Let's look at C. C, they've told us to find the 16th term, and you know that the 16th term, how we go about finding that if we don't have Tn is A plus 15D. And what do? We substitute A, we substitute the difference, which is T2 minus T1, and we get to our answer of 47. So that's the end of our lesson for today. Thank you so much for joining us, and we hope to see you again soon. Keep well.